Good afternoon, students. Welcome back once again to the mathematics class. So, in the last lecture, we have seen what are the applications of integrals and how to plot the area under the curve, as well as the area of a region bounded by the curve and a line. Also, we have discussed. And some examples also we have seen. So, in this lecture, we are going to solve the exercise 8.1, right? So, let's see the first question here. Question number 1. Find the area of the region bounded by the curve y square equals to x and the lines x equals to 1 and x equals to 4 and x-axis they are given here, right? Along x-axis, the curve is along what? X-axis it is. So by using the equations and the line, we plot the graph first. So let's see, we have considered x-axis and y-axis here. It is our x-axis, it's our y-axis. So here, now we are taking the graph y square equals to x. Usually you know y square equals to x. It is formula for what? Yes. Y square plus y square equals to x. Y square equals to 4ax is there. Standard formula. That is what? Ellipse, hyperbola or parabola it is. Standard form of ellipse, parabola, hyperbola. These also we have discussed in yesterday's class. Circle, hyperbola, and parabola also we have discussed. So now the curve, what it shows, y square equals to x is there. Simply y square equals to x is the which conic section it is. It is what? Parabola or hyperbola or ellipse. Y square equals to 4x is parabola it is, right? So parabola with x-axis it is. Y square equals to x they are given. So the standard parabola equation is like this only. The graph how we get is there. So we get a graph like this only. It is parabola, right? So if you know the standard form of a parabola, then it is very quite easy to draw the graph also. So now we have plotted the graph. If you don't know the standard form, then you can put the value by taking x equals to 0, x equals to 1, x equals to 2, then what will be the y value. On the basis of that also you can plot the graph, right? So see here, y square equals to x, we have plotted the graph here. So let's see, in the first quadrant and the fourth quadrant the graph is there. So now actually it is a curve. We have plotted the curve with x-axis, this positive x-axis and a negative x-axis. So the lines also given here, lines x equals to 1, see here x equals to 1 this point, and here x equals to 4 at this point, right? So x equals to 1 and x equals to 4 also we have plotted on the graph. So now here we have to find the area, the shaded region what we are seeing here, the shaded area, we have to find its area. If we find this area, then by using the strip we have taken here, let's see, according to y-axis it is, y is parallel to y-axis right here. So the strip width we are taking dx. Already we have discussed this all in the yesterday's class also. So the width of the strip is dx and the length is y, which is parallel to y-axis. So the area, let us consider it as a, this point as a, this point as b, this is c, and this is d. Got it? Now the curve is y square equals to x. So now we have to find the area of this curve. So let's see. So let's see, the area of a region bounded by the curve y square equals to x and the line x equals to 1 and x equals to 4 and the x-axis is the area ABCD. Let's see, it is A, it is B, it is C, it is D. The area is like this, right? With the curve, which is nothing but A, B, C, D. This reason we have to find by using the strip, right? So let's see, area of ABCD, what we have standard formula, area of ABCD, which is equals to integration, the limit, lower limit, upper limit, we have already given the lines, x equals to 1 to 4. So y dx with respect to the strip is vertical. So with respect to dx we are doing here. So y dx. So value of y is y square equals to x is there. Then y equals to what we get? Root x, right? So root x into dx. So now integrate this with respect to dx. So what we get here? X to the power of 1 by 2 is there already. After integrating x to the power of 1 by 2 plus 1 upon 1 by 2 plus 1, right? So now which equals to x to the power of 3 by 2 upon 3 by 2. So the limit function 1 to 4. So now this 3 by 2 in the denominator goes to the numerator, it becomes 2 by 3. So now apply the limits. Upper limit, that is 4 to the power of 3 by 2 minus 1 to the power of 3 by 2. So 2 by 3 as it is. 4 to the power of 3 by 2 can be written as cube root is 8. It is minus 1, right? So now 8 minus 1 is 7. 7 to the 14 by 3 is the required area of ABCD, right? So next moving to question number 2. Find the area of a region bounded by y square equals to 9x, x equals to 2, x equals to 4, and the x-axis in the first quadrant, right? So let's see here. Again, y square equals to 9x, which is in the form of what? Y square equals to 9x is, it is in the standard form, parabola. So y square equals to 9x. So again we have to plot a graph, parabola graph, y square equals to 9x. So we have plotted the graph here and we have taken the line x equals to 2 here and x equals to 4 on the x-axis. So the curve is drawn, it is y square equals to 9x. So let us consider a strip y along parallel to y-axis and a width dx, and let us consider this point as ABCD. ABCD. So the area of a region bounded by the curve y square equals to 9x, x equals to 2, x equals to 4, and the x-axis, and the area of ABCD is again integration 2 to 4 y dx. Then with the value of y, what we get here, it is y square equals to 9x, that is y equals to root 9x square 3 root of x y value. So just substitute y equals to 3 root x into dx. So 3 outside, root x integration is x to the power of 3 by 2 upon 3 by 2. So here when goes into numerator it becomes 2 by 3, 3 get cancelled, only 2 remains here. So x to the power of 3 by 2 limit 2 to 4. So now substitute upper limit minus lower limit. So here 4 to the power of 3 by 2 minus 2 to the power of 3 by 2. So 4 to the power of 3 by 2 can be written as 8. That is 2 square, 2 to get cancelled, 2 cube is what? 8 here. And here 2 to the power of 3 by 2 can be written as 2 root 2. So just multiply 2 inside the bracket, it is 2 8 is 16 minus 2 to the 4 root 2 units, square units is the required solution. Very easy examples, just you have to find the graph first. The application of integral is nothing but just you have to find identify the reason only here. Major part is just identifying the reason. Rest of all is nothing but that is integration and substitution the limit of a sum. Already you have studied in the integrals. In application of integrals, just to consider the strip and the line, the area, what we are going to find the region, area under the region, or area bounded by the region and a line also. So here the region is a major part. If once if you find the region, then everything is integration only, the normal calculation part, right? If once if you find the reason, then it is enough. So next see question number 3. Find the area of a bounded by x square equals to 4y. X square equals to 4y, which is also type of parabola only. The standard form is what? Y square equals to 4ax. So here the curve is rotating through 90 degree in the anti-clockwise direction. The shape of a characteristics of the parabola becomes x square equals to 4ay. The shape is like this, right? So rotating towards 90 degree. So when it is rotating towards 90 degree, at least the standard form of parabola is what? It is like this. So when we rotate it to the 90 degrees, so it becomes like this, right? So now we have plotted the graph. That is x square equals to 4y. Again, take y equals to 2 at this point, and y equals to 4, right? So in the first quadrant they are given area in the first quadrant. So we have to take a strip x along horizontal with parallel to x-axis, and a width dy along y-axis. So the area of the region bounded by the curve x square equals to 4y, y equals to 2 to 4, y-axis, and the area of ABCD, which is equals to integration 2 to 4 x dy. Right? When it is horizontal, the strip is when it is horizontal, then we differentiate with respect to y, that is dy, right? So value of x square equals to 4y, then x is 4y, then finally we get 2 root of y, the value of x, so it is 2 root y dy. So to keep outside root y dy, again integration of y to the power of half is nothing but y to the power of 3 by 2 upon 3 by 2, limit 2 to 4. Next, when it is go to the numerator, it becomes 2 to the 4, 4 by 3, y to the power of 3 by 2. When substitute the limit, it is 4 to the power of 3 by 2 minus 2 to the power of 3 by 2. 4 to the power of 3 by 2, it is there, right? So we can write it as 2 square 3 by 2. So when it goes numerator, it is 6 by 3. 2 to the power of 2 3s are 6 by 2. So it becomes 2 cube is what? 8. So here again 2 to the power of 3 by 2 is there. So it becomes 2 to the power 2 into 1 by 2. So 2 into root 2. So nothing is there, means when bases are same, power should be added. 1 plus 1 by 2 is 3 by 2, right? So 8 minus 2 root 2. So again when you multiply it inside, what you get here? 32 minus 8 root 2 upon 3 is a common. The units is the required solution. That is nothing but area of ABCD. Next example number 4. Find the area of a region bounded by ellipse. They are saying here ellipse directly. X square by 16 plus y square by 19, which is x square by 16 plus y square by 9, which is equals to 1, right? So already you know the standard form of ellipse also. So let's see here, the standard form of ellipse is what? X square by a square plus y square by b square, which is equals to 1, is nothing but standard form of ellipse. So here we have plot x square by a square means x square by 4 square plus y square by 3 square equals to 1, right? The value of a is 4, value of b is 3. So let's see here, the value of a is 4 comma 0. We have taken here the value of a is 4 comma 0, the value of b is 0 comma 3. So now plot the ellipse by using the fourth quadrant or two-dimensional graph. So you have plotted the graph 4 to 4 and here 3 to 3 plus 3 to minus 3. It is positive y-axis and negative y-axis at 3 and positive x-axis, negative x-axis at 4, right? So we have plotted the graph and we have taken the strip in the first quadrant. Later on we can multiply it by 4, then we get all the 4 quadrant area of the ellipse, right? So let's see first quadrant here. The strip width can be taken as dx and the length of the strip is y, it's a dx, right? So let's see. It can be observed that the ellipse is symmetrical about x-axis and y-axis. The area bounded by ellipse is 4 into area of OAB, right? One side we are finding here. After multiplying all the 4 sides, then you will get the region under the ellipse, right? So let's see. Integration area OAB, just we are finding this region, this much region, right? So integration 0 to 4, integration 0 to 4 y dx, integration 0 to 4 y dx. So let's see y dx as it is. Then value of y is here. Just you have to find the value of y. It is x square by 16 plus y square by 9, which is equals to 1. So y square by 9, which is equals to 1 minus x square by 16 is there. So when it cross multiply this, so what we get, 9 also is there. So 9 into 1 minus x square by 16. So finally y value, which is equals to square root of 9 square root of 1 minus x square by 16. So which is equals to 3 into square root of 9 is 3 into under root of 1 minus x square by 16. So the value of y we have taken 3 into under root of 1 minus x square by 16 dx. So here when you cross multiply this, what you will get, 16 1 to 16 minus x square. So square root of 16 is 4 taken outside. Integration 0 to 4 as it is, that is 16 minus x square dx. So now here 3 by 4 as it is, now it is in the form of a square minus x square. The standard form is there, under root of a square minus x square dx, which is equals to, what we get here, x by 2 under root of a square minus x square plus a square by 2 sin inverse x by a. See, in this form we have the formula. So in the similar manner we have to expand this, x square by a square plus y square by b square, x by a square minus x square, it is x by a, right? So now substitute in the similar manner, x by 2 under root of a square minus x square plus a square by 2 sin inverse x by a, right? So similarly 3 by 4 outside, x by 2 as it is, a square minus x square is 16 minus x square plus of a square means 4, 4 square means 16 by 2, sin inverse x by a value is 4, right? So 0 to 4 we are taking here limit function. So 3 by 4 as it is, when you substitute upper limit, 4 by 2 is 2, 2 ones are 2, 2 so get cancel here, you get 2 under root of 16 minus value of 4 square is 16 plus 8, that is 2 ones are 2, 2 are 8, sin inverse of 4 by 4 is what, 1, minus of, it is 0, 0 by anything is 0, the whole term is 0 here, minus 8 by sin inverse 0 it is, plus or minus we can take. So now 3 by 4 as it is also 0, 8 into sin inverse 1. Sin inverse 1 is what? is pi by 2. So 8 into this term reduces to 0. So 8 into sine inverse 1 is nothing but 8 pi by 2. So 3 by 4 as it is. 2 ones are 2, 4s are it is. So it is 4 pi. So 4 again get cancelled. The finally what we get here, area of AOB is, therefore the area bounded by the ellipse 4 into 3 pi is 12 units. So one side we have got here, if we multiply all the four sides of the ellipse, then we get the final value of the region of an ellipse, that is x square by 16 plus y square by 9, which is equals to 1. That is nothing but 12 units. So next example number 5. Let's see. Find the area of a region bounded by the ellipse. Again, similar problem. X square by 4, y square by 9. So the given equation of ellipse can be represented as, let's see, x square by, so x square by 4. Here a is less than b. So a is less than b. So in this case, the ellipse is vertical. So we have written, let's see, here 2 a value is 2, b value is 3, b value is 3. Let's see here, a value is 2, a is 2 comma 0, b is 0 comma 3. So now strip we are taking according to y-axis, parallel to y-axis, and the width of a strip is dx. So let's see, x square by 4 plus y square by 9 equals to 1. Then the value of y can be written as 3 into under root of 1 minus x square by 4. Take it as equation 1 here. So it can be observed that here again ellipse is symmetrical about x-axis and y-axis, and the area of ellipse is 4 times of area OAB. So similarly substitute the limit 0 to 2 y dx. So just 0 to 2, 3 into value of y is 3 into under root of 1 minus x square by 4 dx using equation 1 here. So 3 by 2, taking outside here 4 also, after multiplying 4 ones of 4 minus x square remains inside the root. The 4 when it comes outside the root it becomes 2. So 3 by 2 taking outside the integration 0 to 2 under root of 4 minus x square dx. So again which is in the form of standard form, it is nothing but x by 2 under root of a square minus x square plus a square by 2 sine inverse x by 8 is right. So it is nothing but the standard form of a square minus x square dx. Integration of a square minus x square dx integration. The standard form already you know well, you have studied in your first PUC. So let's see 3 by 2 as it is, x by 2 under root of 4 minus x square plus 4 by 2. The value of a square is 2, 2 square means 4, 4 by 2 plus sine inverse x by a value is 2. So now apply the limit here, upper limit means what it becomes, 2 to get cancelled here. So again here 2 square means 4 get cancelled. So 2 to sine inverse 1, again 2, 2 sine inverse 1 is pi by 2. So 2 pi by 2 minus 0 neglected here. Lower limit totally becomes 0. So here 2 pi by 2. So here 2 to get cancelled. What we get finally? The value is 3 pi by 2, that is area of OAB is 3 pi by 2. So therefore the bounded area bounded by the ellipse is 4 times of 3 pi, but is nothing but 2 ones are 2 twos are, it is 2 threes are 6 units is the required solution. So next to sixth example, let's see sixth one. Find the area of a region in the first quadrant enclosed by x-axis. Find the area of a region in the first quadrant enclosed by x-axis and the line x equals to root 3y and the circle x square plus y square equals to 4. So first we have to plot the graph by using the given quantities. So the area of a region bounded by the circle x square plus y square equals to 4x and x equals to root 3y and the x-axis is the area OAB. So let's see. Let's have a graph here. X square plus y square equals to 4. Here the radius is what? R is equals to 2. Got it? R is what here? X square plus y square equals to a square. Standard form of circle is what? X square plus y square, which is equals to a square or r square you can take. Here r square means 4 is there, 2 square. A value is what? A value is 2. The radius. The radius distance is from here to here is 2. So we have to plot a circle x square plus y square equals to 4 and we have to take a line root 3y. Root 3y. So when a value they are taking here, when x equals to root 3y, what we get? X equals to root 3y. So it is passing through the origin x equals to root 3y, the value of root 3y. When x equals to 1, what we get? Or it's a line actually x equals to root 3y. So the line we have drawn, which is passing through the origin when x equals to root 3y. Or you can take x minus root 3y equals to 0. X equals to root 3y or x minus root 3y, which is equals to 0. So in this case, this line, it passes through origin only, right? So when x equals to 0, y value is minus 1 by 3 it is, right? 1 by root 3. So when y equals to 0, x equals to 0 only. So it passes through origin. So from this point, it is passing through. So at the point of root 3, value of x is root 3 and value of y is 1. It is point A. What we are taking, that is point A. So in this region, so we are taking the perpendicular line C and it is B, it is C, this is A. So now we have to find the area OAB. OAB, right? So let's see. The point of intersection of a line and the circle in the first quadrant is root 3 comma 1 and the area of OAB equals to the area of the triangle OCA and area ACB. By adding these two, we have to find the area OAB. The area of OAC equals to half of OC into AC. So half as it is, OC is root 3 and AC is 1. So just substitute what we get here, root 3 by 2. The area of OAC. Area of OAC is what? Area of this OAC of the triangle. What we get? Root 3 by 2. So now area of ABC. Let's see area of ABC. This one. Area of ABC. That is integration root 3 to y. Root 3 to 2 y dx. the area of ABC is root 3 to 2. Y value is 4 minus under root of 4 minus x square dx. So again, which is in the standard form. So now apply in the standard form and substitute the limit function, and simplifying we'll get the value pi by 3 minus root 3 by 2. So therefore the area enclosed by x-axis, the line that is x equals to root 3y, and the circle x square plus y square equals to 4 in the first quadrant is root 3 pi by 2 plus root 3 root. So what we get here? So it is actually therefore the area enclosed by the x-axis, x equals to root 3y, and the circle x square plus y square equals to 4 in the first quadrant. So we have here the value of the solution is pi by 3. It is actually pi by 3 here. So I'll write the final answer here. So it is pi by 3 units. So just we have substituted value here, x pi by 3 minus root 3 by 2. So after adding what we get, area of OAC is what here? This area of OAC, just we substitute here only. Area of OAC is root 3 by 2 plus of area of ACB or ABC, that is pi by 3 minus root 3 by 2. So let's see here what we get. 2 as it is, upper limit when we substitute, it is 2 by 2, and 4 minus x square is 4 minus 4 0 plus 4 by 2 into sine inverse 2 by 2, it is 1, it is sine inverse 1, upper limit it is 2 into pi by 2 we get here for upper limit, minus of now lower limit root 3 by 2, it is 4 minus root 3 square, means square root get cancelled, 3 remains, minus of 2 sine inverse of x value is root 3 by 2. So let's see what we get here. Minus 2 ones are 2 2s, right? It is 2. So after multiplying we get minus 2 sine inverse of root 3 by 2, right? So here 2 to get cancelled, pi minus of root 3 by 2 minus 2, this note that it is here pi by 3, right? So now pi minus root 3 by 2, 2 pi by 3. So 2 pi by 3, pi minus 3 pi minus 2 pi is pi by 3 minus root 3 by 2. So just substitute the value here, pi by 3 minus root 3 by 2. Root 3 by 2. Root 3 by 2. So it is plus 3 by 2 minus 3 by 2 get cancelled only. The final value is what here? The final value is pi by 3. So plus minus get cancelled here. So don't get confused this term. So simply what we have here, plus root 3 by 2 plus of pi by 3 minus root 3 by 2. Minus root 3 by 2 plus root 3 by 2 get cancelled only. Pi by 3 limits, right? So the solution is pi by 3 units. So next example number 7. Here also area of a smaller part of a circle has been given based on circle only. X square plus y square equals to a square. The cutoff of the line x equals to a by root 2. So let's see the solution of this one also. The area of a smaller part of a circle x square by plus y square equals to a square. Cutoff by the line is x equals to a by root 2 is the area ABCDA. Let's see. We have taken the circle here x square plus y square equals to a square in standard form. Standard form is there. The value of x is a by root 2 or a value is root 2x we can take. So a equals to x equals to a by root 2 we have taken here. So the points x square by x square plus y square equals to a square is the circle, standard form of the circle. So it can be observed that the area ABCD is symmetrical about x-axis only. So the area ABCD is 2 times of the area ABC. So it is a comma 0 and this point is x a by root 2. So this point as point C is taken as a by root 2 comma 0. It is on x-axis. Y is 0, right? So now 2 times of area ABC. So area of ABC can be found by area of ABC is a by root 2 into a into y dx. So just take value of y is a square minus x square and root of a square minus x square into dx. So again convert it in the standard form, that is under root of a square minus x square form. That is x by 2 a square minus x square plus a square by 2 into sin inverse x by a. Now taking a limit function, just substitute the upper limit minus lower limit. So this is nothing but our upper limit. So this whole term is what? It is for lower limit, right? So now simplifying this, what we get here after simplifying, the value is a square by 4 pi by 2 minus 1. So therefore the area ABCD is 2 times. So here 2 times means here 2 ones are 2 twos are get cancelled. So the final value is a square by 2 pi by 2 minus 1. So basic calculation is there here. Simple integration and simplification is there. If once you find the graph, then it is quite easy. So therefore the area of a smaller part of a circle x square plus y square equals to a square, cut off by the line x equals to a by root 2 is a square by 2 into pi by 2 minus 1 units, right? So next, eighth one, the area between x equals to y square and x equals to 4 is divided into 2 equal parts by the line x equals to a, then find the value of a. They are given. So again x equals to y square means it is a type of parabola only. So let's see the line x equals to a divides the area bounded by the parabola and x equals to 4 into 2 equal parts. So just we are taking x equals to a and x equals to 4. So now we have to find the area OAD, this area OAD equals to area ABCD. The curve we have drawn here, y square equals to x, it is y square equals to 4x. So the area OAD is equals to area ABCD, right? So let's say it can be observed that the given area is symmetrical about what? X-axis only. So the area OAD equals to area EFCD. The area OED which is equals to EFCD, right? So now we have to find the area OED which is equals to 0 to a y dx. So y value is root x here, y square x means y value what we get? Y equals to it is root x. So with y axis means it is positive root x we are taking here into dx. So again root x integration is x to the power of 3 by 2 upon 3 by 2 limit 0 to a. So now apply the limit 2 by 3 and it goes to the numerator, a to the power of 3 by 2. Take it as equation 1. Next we have to find the area of EFCD. Because both are equal here, we have taken. So now see, area of EFCD is 0 to 4 root x dx. You can integrate this x to the power of 3 by 2 by 3 by 2 into 0 to 4 limit. So 2 by 3 take numerator, the denominator value. So now value of x is 4, it is 8 minus the value is nothing but it is 8 minus a to the power of 3 by 2. So now from equation 1 and 2 we obtain from equation 1 and 2 what we get here, 2 by 3 a to the power of 3 by 2 minus 2 by 3 8 minus it is 0. So 2 by 3 is a common, 8 minus 2 by 3 a to the power of 3 by 2, it is equation 1 which is equals to 2 by 3 8 minus a to the power of 3 by 2. So this value is a, actually it is 0 given here, a to 4 it is. Yes, it is a to 4, not 0, it is a to 4, misprint is there. First one is y dx is 0 to a, next a to 4, right? So it is a to 4 is there, right? So here 2 by 3 a to the power of 3 by 2 which is equals to 2 by 3 8 minus a to the power of 3 by 2 is there. So here 2 by 3 get cancelled. So what we have here, simply when we take the simplification form, it is 2 a to the power of 3 by 2 into equals to 8, right? The simple calculation is there here, don't get confused. 2 by 3 a to the power of 3 by 2 which is equals to 2 by 3 8 minus a to the power of 3 by 2 is there, right? So when we multiply 2 by 3, 2 by 3 is common here for both the terms. So in the LHS, if we cancel both 2 by 3, 2 by 3, a to the power of 3 by 2 which is equals to 8 minus a to the power of 3 by 2 remains. So here what we get, 2 a to the power of 3 by 2 they have written here. So a to the power of 3 by 2 into 4 when 2 comes to the RHS, it becomes divided by. So a to the power of a equals to 4 to the power of 2 by 3 it is, right? The power changes when it goes to RHS. Already it is a to the power of 3 by 2. So let's see once. 2 by 3 a to the power of 3 by 2 which is equals to 2 by 3 per limit when you substitute 2 by 3 by taking common, it is 8 minus of a to the power of 3 by 2, right? So 8 minus a to the power of 3 by 2, right? So it is multiplication form is there. So when we take a to the power of 3 by 2, so if we Cancel 3 from the denominator. It is 2 cube. It means 2 to the power of 3 by 2 also it is. So the value is 2 by 3, 2 by 3. So when you take this 2 by 3 here, e to the power of 3 by 3 is 2 by 3, 8 minus e to the power of 3 by 2 by 2 by 3, 2 by 3 get cancelled. So only a to the power of 3 by 2 remains. 8 minus a to the power of 3 by 2. So now 2 comes here, only 8 is there. So when you take this term to the RHS, it becomes a to the power of 3 by 2 plus a to the power of 3 by 2, which is equals to 8. So it is 2 times of a to the power of 3 by 2, which is 8. So finally a to the power of 3 by 2 is 4. So now a equals to 4 to the power of 2 by 3 is the required answer. Therefore, the value of a is 4 to the power of 2 by 3. Got it? So next, question number 9. Find the area of a region bounded by the parabola y equals to x square and y equals to mod x. Then the area bounded by the parabola x square equals to y and y equals to mod x can be represented as, let's see. See the graph we have drawn here. Again, x square equals to y. When the standard parabola, it is a standard form of parabola, when it rotates 90 degrees, so it becomes like this. So we have the line, it is y equals to what? It is y equals to mod x is there, so we are taking modulus positive and negative also, y equals to mod x. So x square equals to y it is. So now we have to find the reason. So it is m, one side if you find. Similarly we can get other side also. So let's say the given area is symmetrical about y-axis. Now the area of OACO, OACO, this area which is equals to area of ODBO, ODBO, this area. These two are equal here, right? So now the point of intersection of a parabola is x square equals to y and the line y equals to x is at 1, 1. Y equals to x. When x equals to 1, y equals to 1, right? So a value is 1, 1. The area of OACO equals to area of a triangle OAB, OAB, area of a triangle OAB minus area of OBACO, OBACO, area of OACO, OACO, which is equals to what? The area of a triangle OAB. This triangle they are saying OAB minus of OBACO, OBACO. Okay. Next, the area of a triangle OAB equals to half of OB into AB. This triangle they are saying conveys when we connect these two lines, so it becomes a triangle like this. The area of OACO is the area which is equals to the area of OAB. OAB, the area they are saying here, so it moves from C, OAB minus OBACO, OBACO. So total, this region is equals to this region minus this region they are saying. OB, it is OBACO. Okay. So the area of a triangle OAB, which is equals to 1 by 2, OB minus AB, that is 1 by 2 into 1 cross 1, so we get 1 by 2 by the value. So the area of OBACO is y dx, it is the limit 0 to 1 we are taking here. It is x square dx, it is integration of x cube by 3, 0 to 1 means 1 by 3 it is. So the area of OACO, which is equals to the area of the triangle they are saying here, the area of a triangle OAB minus OBACO. Let's see, 1 by 2 minus 1 by 3, it is 1 by 6. So finally the required area is 2 times of 1 by 6 means it is 1 by 3 units. Got it? So next, 10th one, find the area of a curve x square equals to 4y and the line x equals to 4y minus 2. So the area bounded by the curve x square equals to 4y and the line x equals to 4y minus 2 is represented by the shaded area OBAO. OBAO, these four dotted lines, OBAO, OBAO, right? So we have the graph x square equals to 4y and the line 4y minus 2. So we have plotted the line 4y minus 2. So the point of intersection also we have here. So it is the point of intersection. It is minus 1 comma 1 by 4 and this is 0 comma 1 by 2. So it is 0.2 comma 1, right? So the shaded region you have to find here. So let A and B are the point of intersection of a line and the parabola. So coordinates of point A are minus 1 comma 1 by 4 and the coordinate points of B are 2 comma 1. So we draw AL and BM perpendicular to A axis. We draw AL and BM. See this AL and BM, this dotted line what they have taken, they are perpendicular to what? X axis. So it can be observed that area OBAO which is equals to area OBCO plus area of OACO, right? So take it as equation 1. This area which is equals to this area. So now the area OBCO which is equals to area of OMBC minus area of OMBO. So now substitute the values here. It is integration 0 to 2 x plus 2 by 4 dx minus integration 0 to 2 x square by 4 dx. So just substitute the value. 1 by 4 take outside. Integration of x is x square by 2 and constant 2 is nothing but 2x. So when we applying limit 0 to 2 as it is, minus 1 by 4 keep outside, integration of x square is x cube by 3, limit 0 to 2. So 1 by 4 as it is, upper limit is 2 square means 4 by 2, 2 to get cancelled, it is 2 plus 2 to the 4, minus 0 neglected, minus of 1 by 4, upper limit is 2 cube is 8 by 3, right? So now 6 by 4 is 2 by 3 by 2 minus 4 1 the 4 2 times it is 2 by 3. It is 3 by 2 minus 2 by 3 is 5 by 6. It's nothing but area of OACO, which is equals to area of OLAC minus area of OLAO. So again integration minus 0 to minus 1 to 0 x plus 2 by 4 dx minus 1 to 0 x square by 4 dx. Again integrating this term, what we get here? 7 by 24. So the required area 5 by 6 plus of 7 by 24 is what? Which is 9 by 18, which is 9 by 8, not 18, 9 by 8 units. So similarly, question number 11 is there. So it's a simple example. Area of horizon bounded by the curve y square equals to 4x and the line x equals to 3. Already we have solved this kind of a problem, that is y square equals to 4x and line x equals to 3. So we have the standard form, that is again parabola. So the area OACO is symmetrical about what? X-axis. So OACO is 2 times of area OAB. So you have to find the reason this one. So 2 times of integration 0 to 1, 0 to 3 it is, right? X equals to 3 is there. Integration 0 to 3 y dx. So y value is 2 root x dx. Integration, what we get? 3 by 2 means it is 8 by 3. Upper limit is 3 means 3 to the power of 3 by 2. So finally what we get? 8 root 3 is the required solution, right? So next, example number 12, it is objective type. Area lying in the first quadrant and bounded by the circle x square y square equals to 4 and the line x equals to 0 and x equals to 4 is, they are asking. So let's see, 4 option has been given: a pi, b pi by 2, c pi by 3, d pi by 4. So the area bounded by the circle x equals to 0 and x equals to 2 we have here. It is x equals to 0 and it is x equals to 2 in the first quadrant, then represented by the area OAB, which is equals to 0 to 2 y dx. So what we get here, y value under root of 2 square minus x square is nothing but 4 minus x square dx. So it is the standard form, a square minus x square. So just substitute the value and simplify it. 2 to get cancelled. The value is pi. Hence the correct answer is what? Correct answer is a, pi. So next, 13th one. The area of a region bounded by the curve y square equals to 4x and y-axis and the line y equals to 3. So again here parabola is there. A is 2, B is 9 by 4, C is 9 by 3, D is 9 by 2. So again plot the graph by using a y square equals to 4x and the line y equals to 3. So I plotted the line y equals to 3. So in the graph, so we have x equals to dy. I take about y-axis. So y square by 4, the value of x is into dy. 1 by 4 taking outside the integration, that is y square integration is y cube by 3. Applying limit function, it becomes 27. 1 by 12 outside. So 9 by 4 is the required units. Therefore 9 by 4 is option B. B is the right answer. So which is nothing but exercise 8.1 completes here. In the next lecture, we will discuss about the area between two curves. Up to now we have taken the area under the curve with a line. So now area between two curves. How to find the area between two curves, we will see in our next lecture. So till then, take care, stay at home, stay safe. Thank you.